Okay, go ahead and turn your notes to the page that has the title at the top, Combining Like Terms. Okay, so to start our notes here, we're going to start with just the definition of what like terms are. Like terms are those variables whose exponents and the variable are the same. So examples, 2x and 3x, right? They both have the same variable and their exponent is the same. It has an exponent of 1. Again, we just normally don't write that exponent in there. Okay, the coefficients do not have to be the same, right? This 2 and 3 are not the same number. But our variables are the same and their exponents are the same, which makes these like terms. So here's an example with a different type of exponent. These are still like terms. They have the same variable, same exponent. For the most part, we will be dealing in this unit with exponents of 1, but later in the year we will see like terms with other exponents. So in this next section in your notes, you're going to go through and look at the pair of terms and determine if they are like terms with stating yes or no next to each term. So pause the video to do this, and then press play when you're ready to see the answers. Okay, so the ones that are no here, C and D is not the same letter, so they're not the same variable. A and B, same reason, not the same variable. V and U, not the same variable. So here, this is one, the yes at the bottom, that some people get wrong. Even though there's no variable, that means these are both constants, which means they are also like terms. So our constants that don't have variables are always like terms because we can combine a number and a number. Good. So when we are solving equations with like terms, we can only combine them if they are on the same side of the equal sign in our equation. Okay. We will learn later next week what to do if they're on opposite sides. But for today, we can only combine them if they're on the same side. So let's look at a couple examples. So first, we're still going to draw our line down that equal sign just so we can clearly see our two sides. So we can see that this 4x and this 9x, they're on the same side and they're being subtracted, which means I do 4 subtract 9, which gives you negative 5x, and then our negative 50 still on the other side. We're going to divide both sides by negative 5 to get x is equal to positive 10. So then when we check our answers too, we've got a variable twice now, or maybe sometimes more. So we still want to use this original equation. We don't ever want to jump to something we did in case we made a mistake. So we're going to plug 10 in for both of those x's, which gives me now 40 subtract 90, which is negative 50. Okay. So pause the video and see if you can do that next one. So there's a 1 in front of this y. So this is really 7 plus 1, which gives us 8y. Then divide both sides by 8 to get y is equal to 7. We're going to plug that in. This gives me 49 plus 7, which is 56. Okay, not too bad. So pause video to write and try both these problems and check your answer. Press play when you're ready to see the answers. So 6 subtract 3 gives me 3a equals 18. Clear the coefficient by dividing, and we get 6. Check this, I get 36 subtract 18, which is 18. Okay, the second one's tricky. Remember, there's a 1 here. So negative 3 subtract 1 is the same thing as adding a negative 1. So we get negative 4g equals 24. Divide both sides by negative 4. G equals negative 6. So again, when I check my answers, I always like to use the parentheses and make sure that I have both the negative and the subtraction sign there. So this makes positive 18 plus 6, which is 24. Flip the page over. Here are 2 more problems for you to try, so go ahead and pause the video and give them a shot. So negative 9 plus 15 gives me positive 6. Divide both sides by 6. T equals 6. Plug that in. Negative 54 plus 15. Or not 15, plus 90, oops, which gives me 36. There we go. Thought I did something wrong for a second. All right, and then here, negative 45 plus 38 gives me negative 7h equals 28. Divide by negative 7. H is equal to negative 4. Plug that in here. 28 equals 28. So these next 2 problems you're going to try are a little bit longer. So there's something a little bit new there. So pause the video and try them first. If you get stuck, play through for a little bit of help if you need it, and then pause when you can continue on your own. So my like terms here, they are still on the same side, but they're separated by this constant. That's okay because it's all addition and subtraction, which means we can actually rearrange them here. So if I make this a problem all addition, then it doesn't matter what order we add things in. So if I make this addition, that's 2's a negative. So then I can combine 6 and negative 2 to get positive 4x. And then I'm just going to bring down that plus 3. So now this should look just like a normal 2-step. So subtract 3 to get 4x equals 8, and divide by 4 to get x equals 2. So again, we want to check in both spots here that there's an x. So I have 12 plus 3, subtract 4 equals 11. So this gives me 15 minus 4, which is 11. So then I got negative 6 plus negative 4. That gives you negative 10x. Bring down that plus 3 again. It's just a 2-step now. Get rid of our constant. And divide by negative 10. X equals negative 2. So let's see, that gives me 12 plus 3. Negative times a negative gives me a positive. So we get 15 plus 8, which is 23. Good. One more for you to try. Pause the video and give it a shot. So this 5 is just going to hang out while I combine my 2 like terms here, realizing that this is a negative 3 plus 2, which gives me a negative 1x. So you can put that 1 there if you want. You don't need to. And then with this 2-step, we need to clear the 5. If it's positive, so we need to subtract. Remembering to bring down my negative x. divide by that negative 1 to get positive x, and then I get positive 12 also. So checking that. 5 subtract 36 plus 24. So 5 subtract 36 is negative 31 plus 24 is negative 7. Right, last thing in the video here is just to look at a couple examples where we couldn't combine terms, at least not yet, because I haven't taught you how. So we cannot combine the like terms here because they are on opposite sides. So there's something else we do when they're on opposite sides, and we'll learn that in a couple lessons. So same thing here. Oops, and I have two different variables also. But if I change that to a t, right, so 1, my variables were different, so they weren't like terms. 2, now these are on opposite sides, so we cannot combine them.